Hari Om, good morning students. In last class we have discussed about what is the geometry and types of geometry, Euclidean geometry, non-Euclidean geometry, analytical geometry, algebraic geometry, we have discussed, and in that we have taken only a Euclidean geometry. And Euclid is a mathematician and is the father of geometry, and Euclid has written a book that is the element. It consists 13 volumes. Is it clear? So we have discussed in all these concepts, and also we have discussed about Euclidean definitions. So in that Euclidean definitions, the definition 1, which is about what point, definition number 2, 3, 4, which is about lines, again definition 5, 6, 7, which is about a plane surface, that we have discussed in the last class. Today we are going to be discuss about another important concept, that is axioms. Axioms or Euclidean axioms. Here, the axioms are the general statements or elementary statements which are self-evident. They are self-evident and which are accepted. They have to be accepted without any question. We have to accept it without any question. This is what we call axioms. Axioms are the elementary statement which you have to be accept without asking any question, because they have the self-evident. For example, take that example of have 10 rupees and another person B has 10 rupees. Both are equal. 10 rupees which is equal to 10 rupees. So easily we can able to conclude. We can easily say that it is a person A has 10 rupees and person B also having 10 rupees. So 10 rupees which is equal to 10 rupees, which are the self-evident. See clear? This is what we call axioms. So here Euclid has given 7 axioms. First now I'll write the definition. Dear students, welcome to the definition. Axioms are certain elementary statements which are self-evident and which are accepted without any questions. They are self-evident which have to be accepted without asking any questions. So axioms are applicable to both maths and science. Axioms which are accepted, which are belongs to both maths and science. And Euclid also called the axioms. The Euclid also what we call common notions. Axioms is also what we call common notions. Euclid called common notion. Is it clear? So take down this one. Dear students, now come to the axiom 1. So we know that axiom. Now we are going to discuss. Euclid has given 7 axioms. We have to discuss one by one. So the first axiom is the things which are equal to the same things are equal to one another. The things which are equal to the same things are equal to one another. So here I'll take an example. Here I'll draw a line segment of the measurement AB of the measurement 10 cm. I'll draw another line segment which is equal to which is CD, which is also equal to 10 cm. I'll take another line segment EF, that is also which is equal to 10 cm. So while observing these 3 line segments, I can write the length of AB is equal to, can I write CD? AB is equal to CD, all are equal to what? 10 cm. And also I can write the length of the line segment CD, which is equal to what? EF. It is also equal to 10 cm. Is it clear, students? Now, the length of the line segment AB is equal to what I can take? CD. So CD is also equal to what? EF. AB is equal to CD, which is equal to 10 centimeter, and CD is equal to EF, which is also equal to 10 centimeter. Can I conclude that AB is equal to CD, CD is equal to EF? Can I write AB is equal to EF? Can we write? Yes. So, here the length of AB is equal to CD, CD is equal to EF. Instead of AB, I can write what? CD. See, AB is equal to CD, CD is equal to EF. Or I write instead of CD, I can write what? EF. AB is equal to EF. That is the length of the line segment AB is equal to EF, which is also equal to what? 10 centimeter. So, this is the axiom 1. That is, the things which are equal to the same things are equal to one another. Is it clear, friends? Dear students, take down the axiom 1 and with example. Come to the axiom number 2. The axiom number 2, what it says? The equals are added to the equals. Equals added to the equals. Then the wholes are equal. Equals are added to the equals. Then the wholes are equal. Suppose I will take a line segment AB, which is equal to 6 centimeter, and again I will take another line segment EF, which is equal to 6 centimeter. Now AB is equal to what? EF, if they are equal to 6 centimeter. Now AB and EF for the two line segments, they are what? Equal in measure. They are equal to 6 centimeter. These are the two equal things. Now I'll add 2 centimeter. I'll add 2 centimeter for both AB and EF. For line segment AB and the line segment EF. Now AB 6 centimeter, I'll extend up to what? 2 centimeter. Up to X. For the line segment EF, what is that? 6 centimeter. And I'll add by 2 centimeter. I'll mark it as 1, which is equal to what? 2 centimeter. Now we are adding equals to the equals. These two are equal things. For this, I am adding the equal thing. Is it clear? Now you can see that AB 6 plus 2. 6 plus 2 AB. AB is what? AX is equal to EF 6 plus 2 8. That is EY. They are equal to what? 8 centimeter. So I am adding the equals to the equals. Then the whole thing is equal. Is it clear, student? This is the axiom number 2. So we are adding what? Equals to the equals. Then the wholes are equal. Is it clear, students? Dear students, take down this one. If equals are added to the equals, then the wholes are equal. This is the example for this. Take notes. Dear students, as we come to the axiom number 3. The axiom number 3 says that if equals are subtracted from the equals, here what we are doing, equals are subtracted from the equals, then the remainders are equal. If equals are subtracted from the equals, then the remainders are equal. Now I take a line segment which is equal to AB, and mark it as which is equal to 12 centimeter, and I will take another line segment EF, which is equal to 12 centimeter. So I have taken two equal things. They are the equal in measurement. AB and CD are equal to AB is equal to CD EF. Line segment AB is equal to the line segment EF, which is equal to 12 centimeter. Now I subtracted by subtracted by 2 centimeter. What it become? Already a line segment for 12 minus 2, what it become? 10 centimeter. Line segment A, I'll mark it as here the one of the point, I'll mark it as F and sorry, I'll mark it as X and here I'll mark it as Y. Up to totally 12 centimeter, we are subtracted by 2. What I'll get? 10 centimeter. X, which is 10 centimeter. E, Y, which is equal to what? 10 centimeter. Because I have subtracted by 2 centimeter. I subtracted by 2 centimeter. 12 minus 2, 10 centimeter. 12 minus 2 is equal to 10 centimeter. Therefore, AX is equal to EY, which is equal to 10 centimeter. So, here the axiom number 3. So, what you can take that if the equals are subtracted from the equals, then the remainders are equal. So, AB and EF are the two equal things. For this, I have subtracted by 2 centimeter. Then 12 minus 2 is equal to what I have taken? 10. Here 12 minus 2 is equal to 10 centimeter. Therefore, we can easily conclude that 10 centimeter is equal to 10 centimeter. Here I have subtracted we have the two equal things. For that equal things, I have subtracted by equal things. That is what? 2 centimeter. Then the remainders are equal to what? 10 centimeter. They are equal. This is the axiom number 3. Take down this students. Axiom 3. If equals are subtracted from the equals, then the remainders are equal. Take down this is the axiom. Dear students, as we come to the axiom number 4, that is the things which coincide with one another are equal to one another. That means if we take the two equal things, take the two geometrical figures can fit completely one into other, then they are essentially the same things. So even though if you take that, I'll take two circles of radius 2 centimeter. Here I'll take a circle of radius 2 centimeter and I'll take another circle of radius 2 circle. When two circles have the same radius, then they are said to be a congruent circles. All congruent circles are going to be completely coincide on one another. Even if you take that line segment AB is equal to 3 centimeter and another line segment CD which is equal to 3 centimeter, when two line segments are the same line, then they are coincide one another because the length of AB is equal to CD which is equal to 3 centimeter. Is it clear? And if you take the two squares of the length of the sides of the two squares is equal to 3 centimeter, then the two squares are going to be, to take the two squares, then they are going to be what? Completely fit on one another. Is it clear? This is the axiom number 4. Dear students, you have written that axiom 4. Things which are coincident with one another must be equal to one another. Here two circles of same radius are said to be congruent circles. All congruent and circles are coincide with one another. Here the two lines segment AB and CD, they are equal to 3 centimeter. Then they are going to fit on another. Is it clear? Take down this one. Dear student, we have that another one is axiom 5. The axiom 5 is the one of the very simple thing, that is simple statement, that is the whole is always greater than the part. Whole is always greater than the part. If you take any whole thing, in that if you take a part, the whole is greater or part is greater, always the whole thing is greater. So, if you take a container of water, a container consists of full of water, and remove some water from it. We are going to remove the water from it. Then, will the remaining volume of water is same as the original water? No. Original water is greater than the which part? Is it clear? So if you take that example, here I'll take an example. Dear student, this is what I've taken a chalk piece, I'll break it. Now this is the part. Is it clear? So this is the whole thing. In that I take the part. This part is greater or whole thing is greater? Yes. Whole is greater than its part. Is it clear? Dear students, the whole is greater than the part. Here I'll take a line segment AB which is equal to 10 centimeter and I'll mark it as the point P on AB now which is equal to 8 centimeter. Is it clear? Here AB is equal to 8 centimeter, PB is equal to, suppose it is a 2 centimeter. Now here AB is equal to 10 centimeter. That is the line segment AP. I'll take another one part of the part AP. That is also line segment AP is equal to 8 centimeter. Is 8 centimeter is greater than 10? No. Here we can conclude that the whole thing AB which is greater than the part AP. Is it clear? Even though you can compare PB with AB. PB is equal to 2 centimeter. AB is equal to 10 centimeter. Therefore, AB is greater than its part PB. Therefore, easily we can conclude that always the whole thing is greater than its part. Always the whole is greater than its part. This is the axiom number 5. Take note, students. Dear students, now come to this one. Things which are double of the same things are equal to one another. For example, if we take a line segment, example 6, things which are double of the same things are equal to one another. Here for this one, here I'll take a line segment AB and C. AB is equal to 4 centimeter and CD is equal to 4 centimeter. Now we are going to double the both the things. Double the things. Double. We have to do double means the AB we have to be extended by what? 4. Again we have to extend it by 4. Here again we have to extend it by 4. Then what it becomes? AB it is and extend up to X, it is a 4 centimeter and B to X it is also a 4 centimeter. Here CD is equal to 4 centimeter. I am going to extend it to Y which is equal to 4 centimeter. Now I am doubling the same things. Then here what it becomes? AX. Line segment AX is equal to the line segment CY. They are equal to what? 8 centimeter. The same things we double, the whole thing will get equal to one another. This is the axiom number 6. Is it clear, students? So here initially AB is equal to CD which is equal to 4 centimeter. Double this line segment, then 4 centimeter become 8 centimeter. Then they are equal to one another. Is it clear, friends? Take on. Dear students, we have to come to the next one, axiom 7. Things which have the same things are equal to one another. That means if you take the two things are equal, the two things if you make into half is half of the same things. Things which are half of the same things are equal to one another. If you take any two things which are equal to one another, if you take half of that, then they are equal to one another. That is the axiom number 7. You can take any example. So if you want, you can take a line segment AB which is equal to 10 centimeter. Again, I will take another line segment CD which is equal to 10 centimeter. So half of this one. Take half of the line segments. Half of the line segments. What will become? Half of the AB is equal to become 5. So if I means I will mark it as up to your x and here I will mark it as y. They are the midpoints. Then what will become ax, which is equal to become 5. Again C to Y, which is also equal to what? 5 centimeter. AX is equal to CY, they are equal to 5 centimeter. So the things which are half of the same things, we are taking the half of the same things are equal to one another. See, here AB is equal to CD, they are equal to 10 centimeter. I have taken half of that one, 5 centimeter is equal to 5 centimeter. This is what they are doing. Is it clear, students? Take down this one. Dear student, as we come to the postulates, axioms we are telling now, we have discussed about the axioms. Now we are going to be discussing about another important Euclid's postulates. So as we come to the Euclid's postulates, here the meaning of postulates. The postulates are the special axioms. These are say special axioms. Axioms which are belongs both maths and science, but postulates which belongs only a mathematics. Is it clear? Axioms belongs both maths and science, but the postulates which belongs to only a mathematics. So postulates are special axioms of geometry that are accepted without logical proofs. We had to be accepted without asking any logical proof. Is it clear? This is what we call postulates. Postulates are the special axioms of geometry which have to be accepted without asking any logical proof. As we come to that geometry, we are going to be take the sum of three angles of triangle are equal to 180 degree. Then we have the proof. Logical proof is there. That you have studied 8th, 7th standard. Is it clear? Again we know that sum of four angles of a quadrilateral are equal to 180 degree. That is also we have discussed. And as we come to that Pythagoras theorem that you have studied in the 7th standard. In a right angle triangle square and the hypotenuse is equal to sum of the squares of other two sides. All these the concepts of geometrical concept have the logical proof. But for these postulates, we don't want any logical proofs. We have to accept without asking any question. Which is these postulates are belongs only for the mathematics. They are not belongs to the science. But axioms that belongs both maths and science. Is it clear, students? Take down this definition. Dear students, as you come to the postulate 1, a straight line segment or a straight line may be drawn from any one point to any another point. That can be line segment. Straight line segment. Take down this one. A straight line segment may be drawn from any one point to any other point. What is the meaning of this? That means a straight line segment. We know that line segment. A line segment which has two endpoints. So we can able to draw the line segment when we have two distinct points. Distinct means separate points. Is it clear? So here I'll take that a line. I'll take 2 points, mark it as A, B. If I join from A to B, so a line segment AB we can able to join to the two end point that A, B. Is it clear? If you take point C and D are the two distinct points. Distinct point means separate point. Now I'll join from where to where? CD. Now your AB is a line segment. AB is a line segment and CD is a line segment. So line segment is formed with the help of two distinct points. When you have two distinct points, we can easily draw the two line segments. Here we can have to see that example. Initially, I took the 2 points A and B are the 2 points. If I join from A to B, it forms a line segment. Here also, I took the C and D are the two distinct points. If I join from C to D, then CD is the line segment. Is it clear, students? Take down this one. Dear student, this postulate one naturally leads two more axioms. Two more axioms. Is it clear? So, this one which is not in textbook, but you have to know this. The postulate one naturally leads to two more axioms. Which are the two more axioms? Only one straight line can pass us through given two distinct points. Dear students, here based on the last postulate one, here this postulate one leads to two more axioms. The axiom one is only one straight line can pass through given distinct point. Distinct means two separate points. What I said here, I take this and this one under 2 point marked as A, B. If I join this one, easily they can have to extend or we can easily pass through that. If we take the 2 points, if we draw a straight line, they can easily pass through the point A and B. Is it clear? This is the axiom one based on the postulate one. Is it clear? Which is not in your textbook. This one is not in our textbook, but that we know the concept this one. So only one straight line. Here I have taken that straight line can pass through the given distinct. Distinct is two separate points. We can mark it as xy is a straight line. xy is passing through the points. Passing through points A and B. Passing through points A and B. Is it clear? Take down this one. Dear students, axiom 2, many lines can pass through given point. Many lines can pass through given point. This is the axiom 2. This axiom 2 which you taken from where? Postulate 1. So many lines can pass through given point. So given point, if we take one point, for this point we can draw many lines. See, we can draw infinite number of points from the given point is 1. So we can draw infinite number of straight lines can passing through a given point, given one point. At one point we can draw infinite number of lines. This is the axiom 2, which comes from the postulate 1. Is it clear, students? Many lines can pass. Many lines can pass. Many means uncountable, infinite number of lines can pass through given through a given point. So here O is a given point, in that it passes many lines. Is it clear? This is the postulate, axiom 2, which is based on the postulate 1. Take down this one. Dear students, terminated line can be produced indefinitely. That means a terminated line is nothing but a terminated line is not a line segment. Here I'll take B is the terminated, because on either side of a line I have the end point. On either side of a line has the end point, is what you call line segment. The line segment is also what you call terminated line. This terminated line we can actually extend in either direction. So xy. So AB is the terminated line and this line I am extending on either side. Either side means both the sides. This is the postulate 2. Take down this one. Dear students, write all exams with your own examples. This is the today's homework. Hari Om. Thank you.